Join me as I dive into the bizarre world of quantum mechanics and tackle the challenge of making sense of its weirdness. In this video, you'll explore the strange world of quantum mechanics, where the rules of physics as we know them seem to break down. Understanding quantum mechanics is a daunting task, and it's not hard to see why. At its core, quantum mechanics challenges our classical understanding of reality, forcing us to reconcile two fundamentally different ways of thinking. On one hand, we have wave-particle duality, where objects can exhibit both wave-like and particle-like behavior. It's a concept that defies our everyday experience and pushes the limits of our comprehension. On the other hand, we have the concept of superposition, where objects can exist in multiple states simultaneously. It's a notion that blurs the lines between reality and fantasy, making it difficult to grasp. The more you delve into quantum mechanics, the more you realize how peculiar it is. The principles of wave-particle duality and superposition lead to some truly mind-bending implications. For instance, according to quantum mechanics, a particle can be in two places at once, and its properties can be entangled with those of another particle, regardless of the distance between them. It's as if the fabric of reality is woven with a thread of uncertainty, making it impossible to predict the behavior of these particles with absolute certainty. The complexity of quantum mechanics is further compounded by the fact that it's impossible to observe these particles without affecting their behavior. The act of measurement itself seems to influence the outcome, making it difficult to discern what's real and what's just a product of our observation. It's a phenomenon that has far-reaching implications, challenging our understanding of causality and the nature of reality itself. Diving deeper into the principles of quantum mechanics, we find concepts like entanglement and uncertainty. Entanglement, in particular, is fascinating, as it allows particles to be connected in such a way that the state of one particle is instantly affected by the state of the other, regardless of the distance between them. This phenomenon has been experimentally confirmed, and it has the potential to revolutionize the way we think about communication and information transfer. The implications are profound, and it's not hard to see why entanglement is often referred to as spooky action at a distance. Uncertainty, on the other hand, is a fundamental aspect of quantum mechanics. It's a principle that states that certain properties of a particle, like position and momentum, cannot be precisely known at the same time. This principle has far-reaching implications, as it limits our ability to predict the behavior of particles with absolute certainty. It's a concept that challenges our classical understanding of determinism, forcing us to confront the inherent probabilistic nature of reality. One of the most famous experiments that exemplifies the weirdness of quantum behavior is the double-slit experiment. In this experiment, particles are passed through two parallel slits, creating an interference pattern on a screen behind the slits. The fascinating thing about this experiment is that the pattern changes depending on whether we're observing the particles or not. If we're not observing them, the particles exhibit wave-like behavior, creating an interference pattern. However, if we observe them, they behave like particles, creating two distinct patterns. It's as if the act of observation itself is affecting the behavior of the particles, highlighting the strange implications of quantum mechanics. The double-slit experiment is more than just a curiosity, though. It provides a pivotal insight into the nature of reality, challenging our understanding of the relationship between the observer and the observed. It's an experiment that has been replicated numerous times, and its implications continue to shape our understanding of the quantum world. By examining the double-slit experiment, we gain a deeper appreciation for the strange and counterintuitive nature of quantum mechanics. In summary, quantum mechanics is a fascinating and complex field that challenges our understanding of reality. From wave-particle duality to entanglement and uncertainty, the principles of quantum mechanics push the boundaries of our comprehension, forcing us to confront the strange and counterintuitive nature of the quantum world. Thanks for joining me on this journey into the weirdness of quantum mechanics. If you have any thoughts on the subject, please share them in the comments below. And if you're interested in exploring more topics related to quantum mechanics, be sure to check out my other videos on the subject.